Okay, we want to solve this equation for x in radians and state the solution on the interval from 0 to 2 pi. Okay, I'm actually going to call this angle theta for a minute. And so this is asking, when is the cosine of some angle theta equal to negative square root 3 over 2? So I'm going to think of the unit circle. I want cosine to be negative, so I'm talking negative in quadrants 2 and 3. And for going to plot the unit circle point, the square root of 3 over 2 is bigger for the x value then than the y. So it's going to be right here and right here. And that would be at when theta was 5 pi 6 plus loops around. This would be if I'm getting all, and then we'll get to the 0 to 2 pi in a minute. And the other angle there, and the one in quadrant 3, is 7 pi 6 plus loops around. Now this particular one didn't ask me for all of these, it just asked me for the ones between 0 and 2 pi, and it needs to be for x, not for theta. So I'm actually going to change this theta now to what it was, which was 3x. Then to get the x alone, I would need to divide by 3, and I would need to do it to each term on this other side. So now the x's alone, I have 5 pi 18ths. I'm going to write that. I'll put it down here. X equals 5 pi 18ths. That would be the first angle before I take any loops around. So that'll be my first one to list. And I just simply got that from this angle right here. Now doing the same thing with the second equation, I would divide by 3. And so the first angle would be 7 pi, 3 times 6 is 18. So there's my first two angles. I don't want all of them, or I would have these answers now, but I just want the ones between 0 and 2 pi. And one of the things to note is if you've got angles that aren't on the axes, it's not zeros or ones, whatever this coefficient is on the x inside of the angle, you're going to get twice that many and need twice that many answers, because there will be 3 of them that came from the angle that fell here in quadrant 2 initially, and 3 that came from the one from quadrant 3. Now they're not in those quadrants by the time you divide them by 3. That'll make them smaller, and so 5 pi 18ths, if you were figuring out where that is, that's going to be in quadrant 1, and so is 7 pi 18ths, because it would be 9 pi 18ths would give us pi over 2. So these are both smaller than that, and they're just angles in quadrant 1. So we need to get a total of 6. It's always double this number then. I need to have 6 angles that will solve this to get between 0 and 2 pi. So the thing we want to do next is go to this first equation and let the k be 1. And if we did that, we would have 5 pi 18ths plus 2 pi thirds. And we're going to get another angle from that. We need to make it into 18ths so we can add that. So that's going to be 12 pi. I'm just going to write it right here. That's somewhere where I can read it. I'll put it over here. 12 pi 18ths. That is 2 pi thirds, but converted to 18ths. So I just need to add 12 to the 5 and get 17 pi 18ths, and that would be my next angle. So I'm going to put that on here, 17 pi 18ths. Okay, now I have 3 angles. I got 2 of them from the first equation, 1 from the second. So I'm going to go to the second equation and take my 7 pi 18ths that I got and add to that the 2 pi thirds, but I'm writing it in 18ths so that I can see how to easily add it. That would be 19 pi 18ths. So that would be my next angle. And you see we're just barely past pi here if you were figuring out where you were. So we've still got to we need 2 more angles before we've got all of them. So we need to go back to this angle 17 pi 18ths and add another 2 pi thirds. And so I could add this 17 pi 18ths with this 2 pi thirds in terms of 18ths. It's 12 pi 18ths, and that would give me 29 pi 18ths. And then I need to do the same thing with this 19 pi 18ths. I need to add another 12 pi 18ths, and that would give me my last angle, which would be 31 pi 18ths. And that's still less than 2 pi, because if you doubled 18 you'd be 36. So 36 pi 18ths would be 2 pi. So we're still within that range, and we've got our 6. If you weren't sure if you should stop, you could take the last one that we got from the first equation here and add another 12 pi 18ths. But when you do that, you soon find that you are past 2 pi. So these are the answers between 0 and 2 pi.